Hello, I'm Nalin. I'll be presenting on governor mechanisms. So we have heard such and such engine of a BMW car has a maximum speed of 300 kilometers per hour. So what exactly restricts the speed to 300 kilometers per hour? That is a governor. Now, what is the need for governors? First of all, in an ideal engine, when the load increases at constant power input, the engine decelerates, the speed decreases, and when the load increases, the speed increases. Now, how can we regulate the speed in this case? It's easy. We don't keep the power input constant. That's exactly what a governor does, which we'll discuss in the subsequent slides. Now, why do we want to keep the speed constant? Because we have a characteristic curve between the efficiency of an engine and the angular velocity of the engine. So it has a maximum at a certain optimum omega. So we to maximize the efficiency of the engine, we target to keep the speed close to the optimum value of the omega which is obtained from the curve. Now, a flywheel is also a speed regulator. But there's a key difference between a flywheel and a governor. A flywheel regulates the speed during one particular cycle about the mean speed at constant load, whereas the governor controls this mean speed of the engine over a long period of time at variable load. I will explain briefly the working of the centrifugal governor. Suppose the speed decreases. Suppose the load on this engine decreases. The speed will increase. As a result of which, the fly balls, which are these balls over here, will fly outwards because the centrifugal force will increase. These balls will fly outwards to increase the radius. Because of this, the sleeve here will move upwards, and this upward movement of the sleeve is magnified by this lever arrangement, which is directly reciprocated onto the throttle valve. So the upward movement of the sleeve will cause the throttle valve to slightly close to control or restrict the fuel supply to the engine. So if the speed increases instantaneously after the load decreases, so almost instantaneously the throttle valve will slightly close to restrict the fuel supply, and that hence restrict the power input to the engine, and hence the speed will come back to its original value. Now I'm going to discuss about the kinematics of a governor. Here I have assumed a model which is that of a Porter governor. The masses of the fly balls are taken as small m, masses of the sleeve is taken as capital M, the arm length is small l, and the distance between the hinge of the arm and the axis of rotation is small e, and the radius of rotation is small r. Capital F is the controlling force, as we call it, which is also equal to the centrifugal force. Now we draw the FBD of the ball, its corresponding equations, FBD of the sleeve, its corresponding equation, and from this we get an expression for the controlling force capital F, which is also equal to m omega square r, and hence we get an expression for omega square. Omega square is nothing but this optimum speed at which we want to restrict the engine. So here omega square is equal to 1 plus capital M by small m into g into a parameter which is dependent on the lengths of the governor. So we found an expression relating the angular speed which we desire to directly the physical parameters. So if we want to design a governor for a greater optimum speed, all we have to do is to increase the mass of the sleeve with respect to the mass of the balls. Now a few applications of a governor. As discussed before, the governors are used to limit top speed of vehicles. They're also used to control the RPM of aircraft propellers. They're also used in some small engines like lawn mowers, portable generators, and garden tractors. They're also used to control steam influent turbines. Thank you. These are few of my references.